Yellowstone supervolcano asteroid impact crater. The Beaverhead crater just west of Yellowstone is one of the largest asteroid impact craters of the world. And there's another one basically southeast of Yellowstone supervolcano, the Cloud Creek, Wyoming, southeast of Yellowstone, which is another asteroid impact crater. And this is the map of it showing it where it is. As you can see, to the east of that is a body of blue. That's the Yellowstone Lake over the caldera. So the Beaverhead asteroid impact in the circle of red you can see there is basically flanking the Yellowstone caldera. It's in Idaho at the border of Wyoming and the Yellowstone supervolcano. This is the huge crack that we learned about yesterday. It's over 2,200 miles, stretching from Seattle to New Madrid fault zone, which is a rift valley going all the way, that crack going all the way up to Canada to the St. Lawrence River. Now this one, the Beaverhead Crater. According to Wikipedia, Beaverhead Crater is an impact structure spanning the U.S. states of Idaho and Montana, estimated at 60 kilometers or 37 miles in diameter. It's one of the largest impact craters on Earth. With an estimated age of 600 million years, it's Neoproterozoic. The impact's origin shatters cones along the crater's perimeter. The shatter cones along the crater's perimeter provide some of the structure's only remaining visible evidence. It's named for Beaverhead region of southwestern Montana, in which it was first discovered. It's in Idaho and Montana. It's right on the border. So, also, one of the other, I was looking for crater impacts, asteroid impact craters in the vicinity of Yellowstone. There's another one. Cloud Creek Crater is an impact crater in Wyoming. The crater, located in Natrona County, 48 miles northwest of Casper, Wyoming, near the center of the geological feature known as Casper Arch. Cloud Creek structure is circular with a current diameter about 7 kilometers, buried beneath the 1,200 meter of Mesozoic rocks. The age of the structure estimated to be about 190 to 20 million years, plus or minus 20 million years, 190 million years old, as opposed to the 600 million years of the Beaverhead crater. So Cloud Creek is younger, and that means that it formed as the result of an impact during the early part of the Jurassic period. This impact feature is not exposed at the surface, but it's known only through the wells drilled for oil and gas. First reported by Donald Stone, Cloud Creek is a circular structure documented using several 2D reflection seismic lines of fair or good quality, gravity, magnetic, and borehole data. The structure has a central core of brachiated, fractured, and faulted rocks uplifted up to 520 meter relative to the normal stratigraphy outside the structure, the core surrounded by an annular trough and a detached fault-bounded rim anticline. The rim anticline defines the 7-kilometer diameter of the structure. When the structure was compressed and upthrown during the Laramide compression, the Laramide compression and morphometric parameters of structures are consistent with known impact structures. The core associated with the positive gravity anomaly, magnetic data cannot be interpreted. Now, Beaverhead, we read in Wikipedia, one of the largest impact craters on Earth, 600 million years ago. And there is, on Science Errors, November, Nov79.com, Yellowstone as an asteroid strike. This is what one scientist claims. Yellowstone as an asteroid strike. It really takes stupidity to assume Yellowstone is a supervolcano rather than an asteroid strike, he says. There's no such thing as a 70-mile wide caldera without a visible rim, nor a supervolcano without lava. It's like an ocean without water. So he's saying, where is the lava if this is a supervolcano? Alright? The Yellowstone area of Wyoming is being referred to by scientists as a supervolcano. It's obviously an asteroid strike. Okay, his thing is, where's the lava? Now, supervolcanoes are being described as a wide variety of things, but Yellowstone is nothing resembling any of them. It's physically impossible to get a significant volcano out of Yellowstone. It's so ridiculous that it shows the motives for corruption in science. These are very strong words from one scientist to other scientists. It is very strong. But if this is the case, that it's not a supervolcano and it's an asteroid strike, that's better for the world because of the fact that it won't have an eruption, right? If it's not a supervolcano. So going back now to this, the Yellowstone Formation has nothing resembling a caldera. Its circular shape is so invisible that it was not noticed until recently. Its circular shape is so invisible that it was not noticed until recently. Being 40 miles in diameter eliminates it as a volcano caldera. There are volcanic lakes that get almost that large, but they are lakes because they are in mountains which create the sides. Yellowstone is flat ground. Volcanoes cannot create a 40-mile diameter caldera on flat ground. The area is bumpy, but that is not what makes the sides 40 miles across. A volcano caldera must be formed by lava, which flows out of the entire area. Nothing can move up out of the earth over a 40-mile area all at once. If the lava comes up in multiple events, they cannot form one circular caldera unless there is an extremely high vertical buildup. Yellowstone has no vertical buildup. Another problem is that the ground area around Yellowstone is nothing resembling lava. It's gumbo, with steam and water coming out in places. Steam and water do not come out of volcanic lava. Wow, this is every sentence is really, it's like an atomic bomb to the fact that it's not a supervolcano. So, another problem, he says, is that the ground around, sorry, I have the air conditioning on, I have a little frog in my throat because of that. There's a problem, another problem is that the ground around Yellowstone is nothing resembling lava. It's gumbo with steam and water coming out of places. Steam and water do not come out of volcanic lava. The formation under Yellowstone has been mapped. Such formation is nothing resembling a volcano. There are cavities under Yellowstone which have been migrating westward for hundreds of miles. You do not get volcanoes out of cavities. There has to be a deep enough flow to get hot, melted lava to the surface starting in the liquid core of the earth. There could be traces of volcanic activity with an asteroid strike, but volcanism does not explain Yellowstone. Okay? And then he goes on to say, when the asteroid punched a hole in the surface of the earth 40 miles in diameter, debris filled the space back up. The debris would have been a strange mixture of everything that exists near the surface of the earth, which is exactly what Yellowstone is. The asteroid would have gone through the earth and hit the mantle on the other side, perhaps creating the Siberian Traps in Russia. The event may have caused the most significant extinction of life forms called the Permian-Triassic extinction event of 252 million years ago. There appears to be two major asteroid strikes and two major supervolcanoes. The timing tells a lot about them. The Chicxulub crater near the Yucatan Peninsula is associated with the dinosaurs dying out in 66 million years ago. At exactly the same time, the Deccan Traps formed in India as a supervolcano. There were huge amounts of lava associated with the Deccan Traps. The Deccan Traps would have been formed as the Chicxulub asteroid in the Yucatan Peninsula went through the Earth and hit the mantle from below in India, as some scientists have theorized. The damaged mantle caused the supervolcano to release huge amounts of lava. The Siberian Traps in Russia formed at exactly the same time as the most significant extinction event of 252 million years ago, called the Permian-Triassic extinction event. The supervolcano which created the Siberian Traps would have been caused by an asteroid going through the Earth and striking the mantle, as occurred with the Deccan Traps. These circumstances indicate that Yellowstone was the asteroid strike which created the Siberian Traps, an extinction event of 252 million years ago. Well, we have been told by the geologists recently that there is a piece of the mantle underneath Yellowstone. So something could have struck the mantle that's lodged under Yellowstone. And here we are, Google Earth, and this is where the Siberian Traps would have been. All of these. This is a supervolcano, and you will see it on the maps. This is it right here. Okay. And we'll go to the area. This is it, Siberian Traps. This is it right here. All of this here. Lava, tuff, and tuffite. Lava is this stuff here. Lava, 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 and the tuffite. All this here. That's it, up to the mountains there. That whole area is a supervolcano. The Siberian Traps, as we see, all this. And let's go back. The large region of volcanic rock known as a large igneous province in Siberia, Russia. The massive eruption event that formed the Traps is one of the largest known volcanic events in the past 500 million years. The eruptions continued for roughly 2 million years. It spanned the PT boundary Permian-Triassic, occurring between 250 and 251 million years ago. The large volumes of basaltic lava covered a large expanse of Siberia in a flood basalt event. Today the area is covered by about 7 million square kilometers of basaltic rock with a volume of around 4 million cubic. Okay, and that's what one of them looks like. Okay, and this is what this article says, that you need lava. And recently they found that it was a volcano cannot create a 40-mile diameter caldera on flat ground. The area is bumpy, but that isn't what makes the sides 40 miles across. Volcano caldera must be formed by lava which flows out of the entire area. Nothing can move up out of the earth over a 40-mile area all at once. If the lava comes up in multiple events, they can't form one circular caldera unless there is extremely high vertical buildup. Yellowstone has no vertical buildup. Another problem is the ground around Yellowstone has nothing resembling lava. It's all gumbo with steam and water coming out in places. Steam and water do not come out of volcanic lava. So he talks about the Yucatan Peninsula 65 million years ago, the asteroid impact there that caused the Deccan Traps in India. So this could have caused the Yellowstone, could have caused the Siberian Traps in Russia. And this is the Beaverhead crater right there, Idaho, Wyoming, and this is Idaho, Montana, sorry, and this is Wyoming, and that is the park actually spans out of the border of Wyoming into Montana and Idaho. So this is the area of the supervolcano. The Beaverhead Impact structure. This one says it's 100 kilometers in diameter, but anyway, southwest Montana and Idaho, and they dated it, and they have the impact. This is where this is it right here. And it's in Idaho, right around Idaho, Montana. This is Wyoming. That's the supervolcano. That's the park, actually. The park extends outside, right there, the park. And that's Yellowstone Lake. And somewhere around here is Hebgen Lake. That's Hebgen Lake, where they had the 1959 7.3 magnitude earthquake. And this is the Beaverhead Impact, just above that little mountain sign. It's right around there. There they are, flying over Beaverhead structure. We note that there is no visible crater form. The structure extending across at least 100 kilometers, maybe as wide as 150 kilometers, has no circular outline. The impact predates Rocky Mountain orogeny. It's before the Rocky Mountains were formed. And he says the red dot represents the approximate area of the Beaverhead impact 600 million years ago in the Cambrian period, where the Earth looked totally different, as you can see. The following three images are courtesy of Daniel P. Connolly. Okay. And here we have the impact crater, what it looks like. That's Yellowstone around there. And, okay, more volcanism in the American Northwest. And we do have volcanism occurring after an impact strike. We've seen that in various places of the world, even recently from the impact craters that were found in southwest Egypt, and also the other one from Google Earth. They found them by searching Google Earth. They went and found them, the geologists found them, and they found that they were also very close to volcanic fields that were created after the impact strike. The force was so great that they went through towards the mantle, and of course that's what causes eruptions as well nearby. So allochthonous, found in a place other than where they and their constituents were formed. Beaverhead impact structure, southwest Montana, Idaho, is an allochthonous, this fragment of 100 kilometer diameter impact structure that was transported some distance eastward during the Cretaceous severe orogeny. Orogeny means oros in Greek means mountain. The birth of the mountain range. Present evidence for the impact consists of shatter cones, pseudo-tactilites, and planar deformation features in quartz. The age of the impact is not well constrained, but is estimated to be Neoproterozoic and Cambrian, 1 billion to 500 million years ago. A large circular cavity, magnetic and topographic anomaly, which could be the root of the impact structure, has been identified near Challis, Idaho. Now this is fact. Okay, the Beaverhead impact structure is fact. Also, the other one, the Cloud Creek crater, is fact. Cloud Creek, I think I've pinned it. Where is it? Let's go back. Going back to, let's go back. Sorry. We have to go back to Yellowstone. It's amazing. Okay, here we are. There it is. Okay. Okay, we have Yellowstone. Let's go in more. Yellowstone, Yellowstone Lake. Hebgen Lake is that squiggly thing there. And we can't find Cloud Creek. Where is it? Cloud Creek Impact Crater is right here. And this is the Beaverhead Impact Crater, one of the largest of the Earth, 100 kilometers in diameter. Okay? And also the fact that, so we do have, pretty old, and this one's younger, 125 million years. This is 600 million years. And this one here is underneath the soil, but they found it's an impact crater. And Yellowstone. Okay, what can I tell you? They have found a slab of the mantle, which is slanting. It's slanting. It is slanting, and they said that the magma plume underneath comes under that slant, which is sort of vertical, and causing the magma to go vertically towards the west, putting pressure towards the west. So, see, we have lava here. You can see it from here. This is lava. This is the Snake River Plate. This is in Idaho. This is lava. That's lava. You can see it right here. This is a lot beautiful, clean lava. And from what the other geologist was saying, there is no lava there. Yellowstone asteroid strike. Okay? I'll leave you links for this. It's very interesting. I had gone to see another man's description of an asteroid striking Yellowstone, but he was going into things I didn't understand. Basically, he had pictures with some circles all over the Earth. But what I wanted to find out is the actual asteroid strikes near Yellowstone, which we have found, the Cloud Creek, and the older one, Beaverhead, which is one of the biggest on Earth. And it could be that Yellowstone also. I'll leave links below for you. Please tell me what you think. This is very interesting. So if it is an impact crater, perhaps it's not a supervolcano. So we don't have that. The good news is that we don't have to worry about a supervolcanic eruption. How's that? If you'd like to join me on my Patreon account, you will hear content not covered by mainstream media. These riveting stories will be based on my research, and I will state my opinions and give my personal insight on diverse and controversial subjects and world events not covered by mainstream media, and not supported by YouTube guidelines. So whatever I have on my Patreon, most of those will not be on my YouTube channel. Please consider becoming a member today. More of the most significant and important videos will be on my Patreon channel. Your support helps me to continue my research and keeps this YouTube channel alive. And we depend on your support, your generous charity, because we help economically challenged families here in Athens, Greece, in Kapota, and we also help the young generation with university tuition and the community around our church. Thank you.